Why do off-by-one loop errors create infinite loops? Imagine writing a simple program to count from 1 to 10. It seems straightforward, but a tiny mistake can turn it into an endless cycle. That's what off-by-one errors can do. When you set up a loop, you tell it when to stop. But if your boundary condition is off by just 1, the loop might never reach its end. For example, if you want to run from 0 up to but not including 5, you should check if the counter is less than 5. If you accidentally write less than or equal to 5, the loop keeps going. It keeps trying to process an extra step that it should have stopped at. In languages like Python, Java, or C, arrays start at 0. So if you want to go through an array of 10 items, your loop should run from 0 to 9. But if you write the loop to run until the index is less than or equal to the length of the array, which is 10, it will try to access an element at index 10. Since array indices go from 0 to 9, index 10 does not exist. This causes an error or makes the loop run forever, especially if the code doesn't handle out-of-bounds access properly. The problem is that the loop condition never becomes false because the counter never surpasses the limit. If the counter is not incremented correctly or the condition is wrong, the loop keeps executing. This can happen when you forget to increase the counter inside the loop or when you use the wrong inequality sign. For example, using less than or equal to when you should use less than can cause the loop to run one time too many. Debugging these errors can be tricky because the loop seems to work most of the time. It might only cause problems with certain inputs or at specific points in the program. To fix this, you need to double-check your loop boundaries. Make sure your start and end points are correct, and your conditions match what you want to achieve. Always verify that your loop counter is changing as expected. A good way to avoid off-by-one errors is to test your loops with boundary values. For instance, try running your loop with the smallest and largest possible inputs. Use print statements or debugging tools to watch your loop counter and see if it reaches the expected value. Also, remember to think about whether your indices are 0-based or 1-based, and write your conditions accordingly. In summary, off-by-one loop errors create infinite loops because the loop stopping condition is never met. The loop keeps executing because the boundary condition is set incorrectly, often by just one unit. Carefully checking your loop conditions, ensuring proper incrementing, and testing boundary cases can prevent these issues. Mastering this will help you write more reliable code and avoid subtle bugs that can cause your programs to hang or crash.